Hello and good morning to you guys. So we're going to talk about factorizing quadratic equations today, and I want to start by giving you a review or by talking about a few things we've already looked at in this unit. Before we even go there, just a reminder, so we're going to do factorizing for today and Tuesday, right? Then on Wednesday we'll have a video call, obviously, to answer any questions, to do some more practice. So Wednesday we'll be doing more practice, answering some more questions. On Thursday I'll give you a study guide. So I'll even post that study guide on Wednesday, so that you can start studying. Thursday will be study guide, and then Friday we'll be doing a unit test. Unit test on Friday. If you would like that study guide earlier, say today or tomorrow, then I can still post it, but Thursday is the day that I will give you class time to purely study and work on that study guide. So in this unit, what are some of the things we've looked at? Well, we looked at factorization. We did a lot of factorization. We started by factoring expressions like this. For example, if this was 4x plus 8 and we factored it into we factored it into 4 open brackets x plus 2. So we looked at that. We looked at factorization by grouping. I hope you guys remember that. Factorization by grouping. We looked at quadratic expression. We looked at polynomials. I hope you remember polynomials, monomials, binomials. We looked at special products. We looked at expansion, because you can factorize but you can also expand. We looked at expansion. We looked at factorizing using special products. Factorizing with special products, that's what we did last week on Thursday and Friday, factorizing with special products. And all of this has been leading up to what we're doing today, which is factorizing quadratic expressions. So when we were talking about special products, a special product was, so we had something like this: x squared plus say 4x plus 4, and then you realize, oh, this is a perfect square, or it's a quadratic expression that I can factorize using special products, right? This is only possible to use special products because this is a perfect square. A perfect square is a quadratic expression that can be written as just one term or one binomial squared. So if I factor this using my special products, I take the square root of 4, which is a 2, and then I'll take the square root of x, which is just x, and put it inside the parentheses, and that's x plus 2 squared. This is what we did on what day was it? Friday and Thursday. So that's all nice and good. If you have x squared plus 6x plus 9 and you want to factorize that and write it as just one term squared, you can say, well, since it's a perfect square and that's a condition, it's a perfect square, meaning it can be written as just this without anything else, right? As just this. So all I need to do is take the square root of x squared, which is x, take the square root of 9, which is 3 squared, right? I have factorized that expression and that expression using special products. Now the question is, what if it's not a perfect square? What if it's something like x squared plus 4x plus 3, right? What if it's something like that? It's not, because remember the previous one on the previous screen was x squared plus 4x plus 4, and that one became x plus 2 squared. Now this is not a 4, so I cannot just take square root, because that square root is not a whole number. I cannot just take square root. So actually this whole expression is not a perfect square, so I cannot use a special product to factorize it. Now I'm going to jump ahead and tell you, and you guys just have to take my word for it, that when I factorize this, I'll get x plus 1, close brackets, x plus 3, right? That's what I'll get. And I'll show you that that's true, because if I go ahead and FOIL it out, remember FOIL, multiply, distribute, if I use distribution method to expand it, I'm just proving to you that I'm not lying to you. This will be x squared plus 3x plus x plus 1 times 3 is 3, which is x squared plus 4x plus 3. So the question is, how do I get from here, right? How do I jump from here to here? How did Mr. William do it? How did I do it in this video? How do I jump from there to there? And that's the point of today's lesson. That's what we're going to be trying to look at today. Before we even go there, I need us to start by solving some puzzles, because it's going to be very easy if we can solve some of these puzzles. The numbers that you're looking at in this expression, because this expression is x squared plus 4x plus 3, and then when it's factored, it's x plus 1, close brackets, x plus 3. These numbers you're looking at have some relationships. This number 4, if you look at it, and then you look at this number 1 and that number 3, it looks like that 4 is 1 plus 3, right? That 4 is 1 plus 3. That's what it looks like, and I hope you guys can agree. And this number 3, if you look at it, and then I also still look at these two numbers, the 1 and the 3, when I multiply those two numbers, you see, 1 times 3, I get 3. And when I add the two numbers, 1 plus 3, I get 4. So we're going to first explore the hidden treasures behind these numbers in solving these puzzles. And then after solving these puzzles, we'll go back and see how we can use this idea of solving this puzzle to factorize a quadratic expression. So let's start with this puzzle. I have the number 1 here, I have the number 4 here, I have the number 5 here. So the rules are as follows. This number 1, I need to break it down into its factors and then write the factors just below it. This equal sign that you see here, this equal sign is where in this area and this area is where I will write the factors of 1. Then I'll write the factors of 4 down here and here, and then I will multiply, and I hope you can see that horizontally I am multiplying this, what would be here and what would be here, to get this answer. Then I'll multiply what would be here and what would be here to get that answer. Then I would add them to get that answer. It might look confusing, but once we start, you guys will see that it's not that difficult. So let's see. I need to get factors of 1. Obviously the factors of 1 are just 1 and 1, right? Because 1 times 1, and I hope you can see that vertically I am multiplying and I have to get the number in the triangle. 1 times 1 is 1, very good. Factors of 2 are, I can say 2 and 2, right? I can say 2 and 2, and this is the beauty of this, is I can do try and error. If it works, I move on. If it doesn't work, I try another combination. So factors of 2, I can say 2 times 2 give you 4, right? Well, let's test that. Now remember, horizontally I have to multiply. So 1 times 2 gives me 2, and 1 times 2 gives me 2. Then you ask yourself, is 2 plus 2 equal to 5? No, 2 plus 2 is not equal to 5. 2 plus 2 is equal to 4. So that means that I need to change some of these factors around. So I'm going to go back and change these two factors of 4. So I can use, I know factors of 4 are 1, 2, and 4, right? I tried to use 2 and 2, 2 did not work. So let me try to use 1 and 4. Because I know 1 times 4 gives me 4. So then I go horizontally. 1 times 1 horizontally this way is 1. And 1 times 4 is 4. And 4 plus 1 is 5. So I have solved that puzzle. Let's try another one. This is another puzzle. This time I have 1, I have 4, and then I have 4, right? So the factors of 1, remember this is factors of 1 are still 1 and 1. Now in my head I know that if I use 4 and 1 it won't work. I will have to use 4 and 2 because the factors of 4 are 1, 2, and 4. I know if I use 1 and 4 it won't work, so I have to use 2 and 2, right? So 1 times 2 gives me 2. 1 times 2 in the bottom also gives me 2. 2 plus 2 gives me 4. I have solved that puzzle. Let's try another one. The factors of 1 are still 1 and 1. That one is easy. The factors of negative 6, let's see. Any two numbers that I can multiply to get negative 6. I can say positive 2 and negative 3. When I multiply them, I get negative 6. That is true. Or I can say negative 2 and positive 3, right? You try an error and see which one works. If I have 1 times negative 2, I'll get negative 2. And if I have 1 times positive 3, I'll get positive 3. Negative 2 plus positive 3 is equal to 1. So I have solved that puzzle as well. Let's try another one. 1, 10, the factors of 1 are just 1 and 1. And I hope you can see that I'm starting with factors of 1, but we'll move on to bigger factors. The factors of 10, two numbers which I can multiply to get negative 10. Those numbers are, the ones I am choosing are negative 2 and 5. Right? Negative 2 and 5. So 1 times negative 2, that gives me negative 2. 1 times 5 gives me positive 5. Negative 2 plus 5 is positive 3. You have solved that puzzle. So that's basically what I want us to do today, to solve these puzzles. And then after solving these puzzles, tomorrow we'll see how we can use this idea of solving these puzzles to find the factors of the quadratic expressions. And the reason for these puzzles is we're trying to figure out what's the best relationship, because remember I started here and I showed you that x plus 1 and x plus 3, these two numbers have properties that can lead to this number and that number there. That's where we started. So once tomorrow, after we've become pros at solving all of these puzzles, we will see how we can use that same setup to solve quadratic expressions. So what I need you guys to do today is do these practice puzzles. I'm going to post them on your classroom. There's a bunch of them. There's this one, there's that one, there's that one, there's that one, there's that one. But I'm going to post them on your Google Classroom, and then that's what you'll be doing for today. If you have any questions, let me know. And I hope you've been writing all of these examples in your notebook. See ya.